Hello, everyone. Hey there. Hello, people. How are you doing?
Hello.
Hey.
Hello.
Hello, guys.
Hello. Hi.
Hello. Hello. Welcome to the class. Welcome on board.
Thank you.
Pleasure. How's it going, guys? Are you okay? All good back there? Doing good. Wow. So, guys, I see there are plenty of people here right now on board, around 29. Huge amount of number here. So let me ask Gurav, is it all registered student? They're going to attend in every session from now on?
There are some people we invited today, so might be from the next class. All our enrolled students who are going to join. But yeah, most of the peoples are. There are around 50-60 people who already enrolled.
Okay,
Yeah.
good. That's good. So guys, for those of you that this is your very first session, I want to tell you that the very first rule of the class is to share your camera. So you need to share your camera with me. I need to see you. I need to have eye contact with you, with all of you. You need to have the microphone, connected microphone. You need to cooperate and contribute in all different topics in the class. And it's going to be a very interesting session for all of us. All right. So can you please, all of you, share your camera with me? There are plenty of you. I will give you around 2 minutes to share your video, right? For those of you that maybe you didn't set up your video, you can share your videos as well. Hello, Abdul Samad. Welcome to the class. Welcome on board. Hey there.
Hello. Thank you.
Brilliant. Others, guys, come in and don't be shy. Share your camera with us, and that camera should be on in every second of the class, so you need to just turn it on every second. So let's just give you some more time for others. Maybe they just want to share their video with us, so you have around 2 more minutes to share your videos, and do not turn it off unless you have some emergency task. And please make sure to attend the class in from now on till the end of the class, right? So basically this session and the session after that, these two, the first two sessions will be very, it's not going to be 2 hours, but mainly it's going to be 2 hours for the general session. But this session and tomorrow's session is going to be around 90 minutes. Okay, so we're going to start the 90 minutes class, but later on, when you're just getting used to the class and the class rules and the labs, and you just prepare everything for yourself for the class, basically we're going to add extra half an hour, right? So for the moment, I just give everyone 2 minutes to just gear up. You have 2 minutes, then we're going to have an introduction part of the class. I want to know all of you at the beginning, then we can just discuss about the general technical topics. All right, we're good to go. Let's begin. Okay, so can you just introduce yourself first of all? Just tell me about yourself. Who are you? What do you do right now? What is your current background? I'm going to ask from the beginning of the list. So the very first person in the list is Abdul Samad. So let's begin with you. Tell me about yourself, Abdul Samad, a little bit, and then we're going to continue to the next one.
All right. My name is Abdul Samad. I was born in Ghana. I did computer science as my bachelor's, but I haven't been practicing it for a while now. So I've been working as a security guard officer. I have decided to come back to, learn what I think it's suitable for me. So, yeah.
Okay.
I live in New York.
Do you live in New York?
Yes, please.
Okay, so you're living in New York right now. And
Yes.
what is your background with the network? I didn't get that part.
I'm not doing anything regarding networking at all. I'm just working as a security guard officer.
Okay.
But I have a background in computer science. I have a bachelor in computer science.
Did you do any network class or any of that? Any other parts?
No. I mean, we did some networking, we did programming, all those stuff,
Okay.
but not into details. I'm trying to now specify in networking.
Sure. Okay. Let's move to the next person on the list. So let me ask Hassan, I guess. Hassan? I guess you're muted. You just mute. Can you unmute yourself and try to?
Yeah. Hi,
Hello.
sir. How are you?
Welcome aboard. Thank you.
My name is 𝐍𝐤𝐬𝐧𝐠𝐬, and I am working as a NOC engineer from last 1 year in Saudi Arabia. So
Okay.
I have done BCA from India.
All right. So what is you're working as a network engineer last 1 years, right?
Yeah, last 1 year as a NOC engineer. Yeah.
Okay. Okay. That's brilliant. Do you have any Cisco certification right now?
Yeah. I done already CCNP.
CCNA, right? Brilliant. Kumar, Srujan Kumar, welcome to the class. Welcome aboard. Tell me about yourself a little bit.
Yeah, good evening, Kave.
Good evening. Well, welcome to the class.
Yeah, good evening, all. Yeah, my name is Srujan, and I work for NCG. I have been working over there since a couple of years. I heard about this course from one of my team lead. He suggested me to go through this CCNP course. Basically, I was working with storage devices like HB SAN switches. I don't have much knowledge regarding this networking. So I'm very much passionate to get this certificate.
All right,
That's
that's
all.
brilliant. Okay, thank you. The next one is Debasis, I guess.
Hi. Hello, Kevin.
Hello, welcome aboard.
Hi. My name is 𝐊𝐢𝐧𝐠𝐬, and basically I am having I'm having approximately 10 plus of years experience in network operation and network engineering. So currently, means I have experience on routing switching, basically my primary skills. Apart from that, I work on firewall, means multiple FTD, Palo Alto. But I just wanted to go through again on my CCNP and core course because this is a totally new syllabus. When I last wrote the CCNP paper, it was different. So I want to go through again the CCNP syllabus and practice and utilize the new skills, the SD1 and everything. So I just want to learn more from this class.
Great. Okay. The next one is going to be who's going to be next? Students is going to be I cannot see your name. Is Bajaj, I guess. If I'm not mistaken.
Hello, sir.
Hello.
My name is 𝐍𝐞𝐭𝐰𝐨, and I have done like BC and masters in computer science, and but I was interested in programming, but like I don't have the job, so that's why I'm doing this course for going to basic details in networking. So this is a requirement.
Okay, thank you very much. So I just started with 5 people at the beginning. So for the next session, I'm going to move to the next 5 or 10 people. We're going to talk with each other about your future career. I just want to know you. Basically, you need to pronounce your name. Sometimes it's a little bit hard for me to pronounce names. So I want to know you during this class time when we can just communicate with each other, basically, because it's going to be very fun if we can know each other and we can discuss about many different topics here. So guys, basically we're going to start with the beginning of the class is going to be about the layer 2, right? I don't know how much you're familiar with the basic layer 2 packet forwarding, but we're going to discuss about that part first of all. So first of all, I would like to talk about the Ethernet layer 1, right? The wiring, the speed, and the duplex, right? I'm not sure how much familiar with that part of the class, with that part of the topics, but we're going to start with that one because it's going to be very basic and fundamentals, and it's going to be a fun foundation topics. Okay, so before we go further into the course, I would like to talk a little bit about the physical layer and physical equipment. As you previously know, we have plenty of devices out there with a network equipment as a network equipment. It could be switches, it could be routers, firewalls, all of these different pieces of devices, they have different responsibilities. And the very first thing is Ethernet. Basically, Ethernet is kind of a layer 2 protocol. And this Ethernet needs to have some media to transfer the information, transfer the data into the real medium, right? For example, your medium could be maybe copper, or it could be fiber, it could be any other types, all right? But to play with those Ethernet basic, we need to know what is this Ethernet and how it performs. Okay, is there anyone here just want to start to tell me what is the Ethernet from the beginning? Do you know what is the Ethernet? Anyone here? And guys, in this class, when you just want to talk about the Ethernet, please just raise your hand, right? Because if you want to manage the class, so there is an option here somewhere, I guess, in the reaction button, there is a hand rising button. Okay, there's a raise hand button, like me. Okay, do you see my raise hand? I have a raise hand. If you want to talk, you can just raise your hand and start to talk. Okay, who wants to talk, first of all? Go on, Bajaj.
I think so. It's Ethernet is the cable, like a fiber is a cable. And we have the Ethernet type and Ethernet frame as well. But I just seen in the hexadecimals, the Ether type, or I'm not sure, but like a little bit this information I have.
So basically, Ethernet is kind of a very old protocol, okay? At the beginning, it has been designed by a couple of different companies. I guess the very first company was Xerox that have been created this protocol, and it was a PhD dissertation or something, and they had designed this protocol for some of the purposes. Then later they just use this Ethernet for transferring the data into the wire, okay? Basically for the bus or star or full mesh topology, they have been designed this protocol to transfer the data into that network, okay? And nowadays, mainly this Ethernet has different responsibility and it has a different character, okay? It is pretty flexible. You can use the Ethernet in the WAN, you can use the Ethernet on the LAN. So basically it depends on your, where you need to use this protocol. You can use this for the traffic forwarding, right? So basically, it's kind of a very interesting protocol, and it can interact with the clients and also with the network equipment, okay? There are plenty of those network equipment that can interact with each other. So the very first thing that you need to be aware of that is the network media for the Ethernet packets. So if you want to transfer the Ethernet traffic, you need to have specific Ethernet let's say transceivers or media. There are plenty of them out there. You can use them to transfer the data into the other side. For example, a PC network, okay, a PC network, let's say you have a PC which is connected to the network. Guys, do you see my drawing?
Yes, visible.
Yes, we can.
Okay, so basically a PC has a network interface card, a NIC, and this NIC is connected to a network. Most of the time, it is connected to the network with the copper, right? I haven't seen any PC which is connected to the network with the fiber links. But these PCs are connected to the network with the copper, okay? And these copper, which sometimes we call them twisted pair, okay? So if you want to know more details about them, you can go to the Network Plus class or the CCNA class to learn about them more, okay? But anyway, you just connecting them to the network with a twisted pair cable. Either and there are different varieties of the twisted pair cable. It could be Cat 5, Cat 6, Cat 7. I'm not quite sure about any other new version of them. But you can just read them in the internet if you want to know about them. But anyway, those and these network cable is also connected to a network equipment, okay, which is going to be the first point that is going to connect you to the outside world. Now, most of the time, it is called switch, or it could be a hub. And this switch, don't worry about the hub. We are not going to talk about the hub anymore. I just want to write it down in your to record it in your video. But anyway, it is going to be connected to a Cisco switch, right? And this is going to be a switch port. We call them switch port. And what is this switch port? So basically, each Cisco switch port, it has, first of all, it has some layer 1 characteristics that is going to use the negotiation with the client in order to identify the speed and duplex of a specific interface, right? Anyone here knows what is a speed and what is a duplex? Do you know that?
Yeah, I know.
Okay, go on. So, all right. Kumar.
Yeah, speed means some devices communicate over a bandwidth of 10 Mbps, some over 100 M, some over 1 gig, some over 10 gig.
No. No. First of all, that is wrong. Okay. So when you're talking about the bandwidth, is different with the speed. Speed is a layer 1 characteristics. Okay. So guys, when you're just raising your hand, do not lower it until you finish your speaking. Okay, because it just push you on the top of the list, and everybody else can see you as well. So Michael Kiaga.
Hello class. Just respond to speed. I think speed basically or easily would be the transmission, the rate at which, in this case, we are talking about a network card or copper cable, the rate at which it can transmit, like which transmission can go through, how much and at what capacity can go through. I basically think that is what we mean by speed. Then duplex is communication, because I made to understand we have is it full duplex and half duplex? Is communication to and from or communication from only? So it is like transmission can go both ways. It can go and then come back, or it can only go.
All right. So it's basically somehow is correct. So let me tell you something. The speed, you're correct. So these speed and duplex are physical character of a media and the switch port. We have a different type of speed and we have different type of duplex. The duplex could be either half or it could be full, right? So basically the switches, they are responsible to connect the endpoints, either the clients, the printers, the modem, I don't know, maybe even the routers, the servers. They are responsible to provide the connectivity for these kind of devices to the rest of the network, okay? For example, when you just want to send your traffic out of the network, or you just want to send your traffic, the PC traffic, to somewhere else, even in the same switch, this switch is responsible to forward this kind of traffic. And for the very first step, they need to provide the speed and duplex information. So basically, the speed is kind of a link pulses, okay? For example, if you're using the electricity for not for example, not the fiber, all of the switches, the Cisco switches mainly, they can sense the speed by using a method which is called fast link pulses. And these fast link pulses is for the auto negotiation process, right? So this switch is going to negotiate these parameters with the client and identify, for example, this is the link and the bandwidth, the speed is 1 Gbps, 1 gigabit per second of, for example, but this is the speed of the link, right? Sometimes it is an electrical signal, sometimes it is not an electrical, it's a fiber optic links. So we have different methodology for them. I just gave you an example for that. But also this duplex. This duplex is when the switch is just working either in the send, in the transmit mode, or receive. It cannot act as them both at the same time. For example, the switch can either send the traffic, okay, at a time, or somehow receive the traffic at a time. Not both of them at the same time. It is called half duplex, right? Half duplex. So when you're just sending and receiving the data at the same time, it's called full duplex. Which one do you think is better? Full or half?
Full duplex.
Full duplex. Full duplex. Okay. As the name implies, so the full duplex is going to be much better. And most of the modern network and the modern network equipment, okay, either even the endpoint, they do not support the half duplex anymore. So any speed above the 1 gigabit per second, it is not supporting the half duplex anymore. And most of the Ethernet devices, they can use the full duplex, and sometimes you just write them down as a FDX and HDX. So if you see these kind of things in the documents, so FDX stands for full duplex and HDX stands for half duplex. Okay, so this is going to be one of the other characteristics of the Ethernet. Okay, so basically the very first thing that we are going to do is the auto negotiation procedure, and the auto negotiation is a way to identify the speed and the duplex, okay, by using something called FLP, or the fast link pulses. Okay. Is there any other question? Is there any questions so far? Bajaj, yeah.
So is the speed depends on the Cat5 or Cat6 cables, or is it depend on the full duplex half
Rajat,
duplex?
I guess you have the internet problem. So can you do me a favor? Can you just write down your question in the chat box, because I didn't get your question.
Can I repeat again, please?
Sure. Repeat it again. What did you say?
Yeah, I just asking. Is the speed depend on the cables Cat5 or Cat6, or it's depend on the full duplex, half duplex, like what we can say?
So basically, you are absolutely correct. It depends on the media. It depends on the network interface card of the endpoint. For example, if you connect it to a specific network interface card, and also it depends on the port of the switch. It depends on all of these different types of different parts. So basically, when you're just connecting a node to a switch, okay, and this switch and the speed of this interface, it depends on. Hold on a sec. So if you want to identify this port speed, it depends on the media. For example, if it is a Cat6, the maximum capacity of the media, the maximum capacity of the switch port, and also the maximum capacity of the network interface card. And most of the time, the speed is static. It has a static value. For example, sometimes it says the speed of this interface could be 100, 1, or 10. That means it could be 100 Mbps, 1 Gbps, or 10 Gbps. Okay, so one of these values could be selected. Not all of them, but one of them could be could take in place. Okay, so this is the point. And yes, you're correct. It depends on the all of these different part of a network. Okay.
Thank you, sir.
No worries. The next topic will be about the collision. I don't know if you're familiar with the collision, but I guess you're supposed to know about the collision. Anyone here knows what is the collision? I guess I doubt you know what is a collision inside the network.
May I?
Sure.
Yeah, if multiple devices communicate over a LAN network simultaneously, there are chances of collision.
Okay, so who are you, first of all? Can you raise your hand?
Just 1 second. Yeah, I just joined actually.
Okay, can you introduce yourself, first of all?
Myself, 𝐍𝐞𝐭𝐰𝐨 Francis. I'm currently working in Huawei Technologies. I have 5 years experience in routing and switching.
Okay, so basically your voice is pretty bad. I barely can hear you. It looks like you're speaking from look like a robot. I guess there's a filter on your voice. I cannot hear well, but you can just say it again, or you can just change your microphone. Maybe you restart your system and come back here again, because your voice is pretty bad at the moment. Okay.
Is it clear now?
Not bad. Go on.
Yeah. So you want me to repeat what I meant regarding collision, right?
No. Can you just make sure that your microphone is working properly? It's not working very well right now. And also make sure to turn on your camera as well after you come back. So guys, let me tell you something. So basically the collision, when two people that in the original Ethernet segment, sometimes the collision is happening when on a shared medium, when two people at the same time are just sending their data. Let's say, for example, you have a hub, right? And when these different clients are connected to that hub, let's just give an example. Imagine there's a single medium on that hub, and all of these nodes have access to the same shared medium at the same time. Let's say it is look like a bus, right? It's look like a bus topology. So when they're all talking at the same shared medium at the same time, then it's going to be collision, right? And what is a collision domain? The collision domain is a domain has the potential to see the collision. So let's say, for example, all of these nodes, they're all in the same collision domain, okay? So there's a set of devices that can send a frame. Okay, guys, first of all, the frame is a layer 2 characteristics, okay? It's called to the layer 2. Are you all okay? Can you hear me well? Do you have any difficulty to hearing me?
No, it's fine.
No, sir. It's okay.
Okay, very well. So I've told you the collision domain is a set of devices that can send a frame that collide with the frame sent by another devices in the same set of devices. For example, when the PC1 is sending that frame into the network and PC2 is sending another frame to the network at the same time. So then there will be a collision is happening in here, right? So before the advent of the LAN switches, the Ethernet were using these collision domain regularly, okay? So basically, the hub has a logic to create one single collision domain, right? So this hub is going to have one single collision domain. Means only one node can speak at a time. Other nodes, they need to wait for the first node to finish up the conversation, and the second node can have access to the medium again. But nowadays, by adventing these Cisco switches, or let's say any other type of switches, Juniper switches or any other switches, okay? By adventing switches, based on that switches have the same cabling and signal regeneration as the hub, but the switches, they do a lot more, including sometimes they're just reducing or even eliminating the collisioning by buffering the frame, okay? Basically, the switch is just acting as a repeater, first of all, and they also provide you a huge amount of collision domain, right? It means every single port will be inside one single collision domain. For example, you have the very first port, E0/1, okay? And this very first port is a collision domain, separate collision domain, okay? And basically, there's a node which is connected to this very first port. The second port is going to be E0/2. Again, there will be a node which is connected to that one. The E0/3, another node which is going to be connected in a separate collision domain. And honestly, there will be no collision in these kind of network because every single device is in a separate collision domain. Am I clear?
Yes.
Yeah. Excuse me? Hello.
Go on. The first, hold on a sec. Michael.
Okay, so what happens if, because now if on the switch, each port is in its own collision domain, does that mean if I extend one port to another switch, the other ports also of the other switch, will they be in the collision domain of this particular switch, or these other ports also will create their own collision domains?
Okay, so first of all, yes, they will be in the same collision domain. So you are asking about this scenario. So you are asking me what's going to happen if I just use an uplink port. Okay, we call that an uplink port between two different switches, switch 1 and switch 2. Would it be in the same collision domain? Yes, that's correct. There will be in the same collision domain, but there will be no collision, right? Okay,
So
there will be no collision.
what happens to the other connections of the switch 2?
Okay, so basically they're both in the same collision domain, but if they're working in a full duplex mode, okay, basically in the full duplex, one of them can send at the same time and the other one can receive at a time, okay? They both can send and receive the data in different wires, okay? So there will be no collision in that network, okay?
Yes, maybe just to further. Now on switch 2, say switch 2 has other 8 ports. And we have different devices connected on the 8 ports.
Okay. Yeah.
So are these 8 ports also still in the same collision domain?
No, absolutely not. Absolutely not. Remember, every single physical port, okay, every single physical port, it's going to have separate collision domain. So it is going to be one single collision domain. And every one of them will be single collision domain also, okay? These are different collision domain. So the potential of experiencing a collision in this kind of scenario will be near zero. It's not linear zero, it's maybe near zero, right? Do you understand me?
Yes, thank you.
No worries. Bajaj?
Sir, I have a question like if like in switch port, like there's no collision domain, but the switches do the broadcasting as well. Would it affect on the collision? And I got other question for the switch.
Again, your voice is breaking. Your voice is breaking again. Can you make sure your internet is working properly? I barely can hear you.
Can you give me just a second? I'm just repeating again. Like, sir, I just asking if.
No, sorry about that. Okay, if you want Butters to ask a question, can you just write it down in the chat box? All right, okay. So let me tell you another story about the collision. So when the switch receives a multiple frame on a different switch port, okay, so is there any potential to experience the collision, even if, let's say, for example, all of these ports, they're just sending a huge amount of data to the switch port at the same time, all right? All of them. Would it be a problem? Basically, it depends on the switch characteristics and the generation of the switch and even the platform itself. But the switch can store the frames, all those frames, into the memory, buffer them to prevent the collision. So basically, switch has different type of solution to overcome this issue. For example, imagine the switch received 3 frames at the same time. Okay, and these 3 frames are just entering on the 3 different ports. They all must exit on the same switch port. Okay, so for example, these 4 switch port, they're just sending the traffic, and the traffic needs to just be forwarded on this uplink ports. Okay, the switch simply store the 3 of the frame into the memory, forwarding the very first one sequentially, okay? It's just forwarding the first one and the second one and the third one and the fourth one, and switch has different mechanism to overcome this issue, right? Okay? So this is kind of, oh, hello, yeah. Go on, Bajaj, do you want to ask a question?
No, sir, that's it. Like, you mentioned it, like, 3 frames. Yeah, I got understood. Thank you.
No worries. Michael?
Yes, so since we are talking about collision domains or collusion, so, and you're telling us a switch has different mechanisms of eliminating the collisions. So which device would we expect a collision to occur through? Which device would be sending packets? And so in case you're like, I'm using this device, I am expecting collisions. So in future, it helps us eliminate use of those equipment or devices.
I guess there is no device with, making that collision or supporting the collision anymore. There are no devices out there. And most of the devices, they're just separating the collision domains from each other, right? So there will be no chance to see that collision anymore, in my opinion, unless you're just using a pretty old-fashioned devices, let's say hubs, okay? Or the very, I'm not quite sure, maybe very old-fashioned layer 1 devices. These kind of devices, yes, they may cause a collision into the network environment, but these new type of devices, no, they won't, right?
Out of curiosity,
yeah,
if the devices they are making lately, we do not expect to have any collusion or anything. Do we really still need to study about collusion?
No, honestly, no. I don't believe that you're going to see these kind of things anymore. It's pretty old. It's look like me. So you're not going to talk about the old-fashioned device. Okay, all of the new devices, even the stupid one, there are plenty of these stupid devices. They're also going to separate the collision domains from each other. Anyway, okay. Guys, I just want to tell you about the OSI layers as well. I guess you already know them. What is the OSI layer? Basically, according to the OSI layer, if you remember, we have 7 different layers: physical, data link, network layer, transport layer. What was the next one?
Session.
Yeah.
Correct. Session.
Presentation application.
Presentation and application.
Right. Presentation and application. Okay. So we're going to talk about these very first 2 layers. From now on, we're going to talk about these 2 layers, and mainly we're going to focus on the data link. First of all, the word frame refers to the bits and bytes include the layer 2 header and trailer, along with the data encapsulated by the header and the trailer. And the term of the packet is most often used to describe the layer 3 headers and the data without the layer 2 header, meaning that when you're just forwarding the data from the application layer, each layer is going to add a new header in front of the packet, and this header is going to identify a responsibility of that specific layer. For example, presentation layer is going to add a new header, and it's going to add its personality to the beginning of the header, to the beginning of the packet. Then the packet will be encapsulated in a new packet. Then the session layer is going to add its own header. Again, it's going to repeat the same strategy. It's going to be encapsulated with a new packet, right? Let's say it is actual data or payload, and then the transport is going to add a new header. The network is going to do the same thing. It will be the data, a new IP header, and when it arrives at the data link, you're going to have header and the trailer. At the end of the data and at the beginning of the data, both of them will be there, okay? The header and the trailer. And the word of frames is going to be is going to talk about these data, right? The data plus trailer and the header all together is called frame. And most of the time, the term of the packet, it refers to the layer 3 header and the data all together. It's called packet. Do you get me? Do you get my point?
Yes.
Yes.
Okay, brilliant. And each one of these layer, network layer and data link layer, they're going to have addresses, separate addressing mechanism, okay? And we would like to talk about them in details.
So can you please repeat again the data and header? What is that like?
Okay, for the data and the header in the layer 2 all together, sorry, the data, header, and the trailer all together is called frame in the layer 2, and the data plus header in the layer 3 is called packet. This is a layer 3 term, and this is a layer 2 term. Clear?
It's
Okay.
the trailer, but he said the T1, what you call?
Basically, the trailer at the layer 2 is just holding something called FCS, or frame check sequence. It is responsible to check to sequentially check the frame whether it arrives correctly or not. For example, if there is any noise in between, if there is any packet loss in between, it can realize that kind of issue and it can notify the sender to retransmit the data again, right?
Yes. Okay. Thank you.
No worries. Okay. And about the Ethernet, we talked about the Ethernet. So basically, Ethernet is one of the network protocol for the layer 2. And this is a layer 2 terminologies, okay? And most of the time it's used for the LAN traffic forwarding. They have other purposes for the Ethernet. You can combine this Ethernet with some other protocol to use in a WAN environment or many other different environment, but most of the time we're just using these Ethernet for the LAN environment, okay? So Ethernet has its own addressing scheme. It has its own addressing mechanism. It's also frequently called MAC addresses, okay? And I guess most of you know what is the MAC addresses. Basically, the MAC address is an address that is assigned to every single network equipment that is just working interactively with the network, okay, within a network. For example, if you have a client which is connected to a switchboard, this network interface card is going to have an individual MAC address. And MAC address is consisting of 2 different parts. This is, in total, it's a 6-byte length, or you can call this 48 bits long. Sorry, 48 bits. Consisting of 12 different hexadecimal number. For example, this is a MAC address. 1, 2, 3, 4, 5, 6, 7, 8, 9A, B, C, right? This is going to be a MAC address. And this MAC address is basically 6 bytes in length. And there are 3 types of MAC address. A MAC address could be either unicast, multicast, or a broadcast. This is going to be 3 types of Ethernet MAC address, okay? First of all, what is a unicast? Can you tell me about the unicast?
I think it can only transfer to the one device. You know, it's going to the data is going to the
one-to-one communication.
It's a one-to-one communication.
Okay, it's a one-to-one communication. One node is sending traffic to another node, right? How about the multicast? It's called one-to-many. Not any, but many, right? It's called multicast. And how about the broadcast?
One-to-all.
Sorry, what is that?
One-to-all.
One to any, right? One to everybody. Sending one node to everybody in the network, okay? It is called broadcast. So we have 3 different types of sending the data. And most engineers, they think they know what is the MAC address, but honestly, they do not know that. Basically, if I want to open up a single MAC address, let me just open up one single MAC address for you. Okay, let me say, for example, this is the MAC address consisting of 6 different bytes. This is going to be very first byte, second, third, fourth, fifth, and 6th byte. So basically we have 6 different bytes. The very first part, you can just divide it in 2 different parts. The very first part and the second part. The first part is called OUI. This is called organizationally unique identifier part, Okay, the first half of the address, which is an OUI, is going to identify the vendor. Basically, the IEEE, the organization IEEE, assigned each vendor the very first part to use on that specific devices to identify who's the inventor of these devices, who has provided this device. Is it belong to the Cisco? Is it belong to the Juniper? It has been created by, I don't know, maybe some other companies, okay? The FortiGate or any other company, they are going to use the very first part, first three parts uniquely is assigned to every single vendor. For example, this is going to be for Cisco. For example, CCCCCCC is for the Cisco. Okay. If you see all of these first 6 number, if they're all, for example, C, they're going to represent the Cisco vendor. Okay. If you want to know who's the creator of a single device, you can copy that MAC address and search it in Google. And the Google just shows you, okay, this device, it belongs to the Cisco or Juniper or somebody else, right? And the second part is called vendor assign. Then the vendor is going to assign the second part by itself, okay? So vendor is going to subnet this address and it's going to assign to different piece of devices. For example, it's going to assign to the Cisco switches, to the Cisco routers, to the Cisco access point. Every one of them, they're going to have a separate, individual, unique MAC address. Hopefully, it's going to be a unique MAC address. There's a potential, there's a chance of finding a duplicate MAC address even within a network, but most of the time, we're just expecting to have a unique MAC address within the same network, right? Okay, so this is called the most and the least significant byte, okay? This is the most significant byte. And this is the least significant byte. Okay? The most significant byte, which is going to be the very first byte, it has a responsibility. The first byte, even itself, let's just open it up. It has 1, 2, 3, 4, 5, 6, 7, 8. This is the most significant byte. It has 8 different bits, starting from the most significant bits to the least significant bits, right? Again, this is the most significant. And this is the least significant. Okay, these are these bits. And inside here, there are 2 different bytes that have a very special responsibility. One of them is called IG, and the other one called UL, right? You thought that you know what is the MAC address, right? You thought that you know that. But now you just see some new information, even with the MAC address, right? So guys, within these very first 8 bits, okay, you can identify the reason of a single MAC address, okay? This is, these bits are going to identify the purpose of a single MAC address. The IG stands for individual or group. And if the binary of that part is 0, it means individual, means that the address is unicast. If the bit is 1, means that the address is either multicast or broadcast. So IG stands for individual or a group. So when it is 1, it means that this is a group address. Means that it's going to be used either for multicast purpose or the broadcast purpose. And the UL stands for universal or local. The binary 0 again means that this address is vendor assigned. For example, the Cisco has created a device and it has assigned the MAC address by itself. And the binary 1 means that the address has administrator. The administrator have been decided to assign an address to all of those clients, right? Okay, to assign the MAC address by itself. How about that? Okay, so in this case scenario, then your address will be, the UL bit will be 1, not 0. So IG, the purpose of the IG is for individual or group purpose, and the UL purpose is for either universal or local, to identify whether this address is going to be assigned by the vendor or by the administrator itself. You may ask me, Kaveh, why do I care about these kind of information? Do I need to know them all? Yes, you do, right? Yes, you do need to know them all. Basically, you need to understand how these kind of thing performs inside the network, okay? I mean, for example, if you're just eavesdropping a packet, if you're receiving a packet from a client, you need to open it up, look at the MAC address. If, for example, the last bit is 0, you're going to say, hey, this is a unicast MAC address. If it is 1, then you can say either it is a multicast address or the broadcast address. Okay, can you tell me about the broadcast MAC address?
OLF.
Yes.
Correct. When it is OF,
Yes.
FF, column FF, column FF. Guys, can you hold on a second? Sorry.
Yeah.
I think you're on mute, Kaveh.
He's talking over the phone.
I'm so sorry about that. Okay, so the broadcast address is OF. Okay, they're OF, FFFFF. It's just representing the broadcast address. When the traffic is receiving on the network equipment, such as a switch, with the destination of the broadcast address, then the traffic will be flooded within the same broadcast domain. So you're going to understand the second terminology of the day, that it's going to be the broadcast domain. What is the broadcast domain? Can anyone tell me what is the broadcast domain here? Anyone here knows what is the broadcast domain? Go on. Oh, it's pretty hard to pronounce your name. Himanshu, if I'm not mistaken. Sorry about
Yes, that's correct. My name is Himanshu Shekhar.
Himanshu.
Yeah.
Welcome on board and go on.
Yeah, thank you. So the broadcast domain means anyone in the shared network, anyone will broadcast the message. All of the users or a receiver will receive the same broadcast messages at the same time in the connected broadcast area.
Okay, so simply it's okay. So basically it means that when you're just sending a broadcast, whoever is in the same broadcast domain is just receiving that packet. Mainly it means, for example, when you're just sending a broadcast traffic to the switch, right? To the switch 1, for example, then if the destination MAC address is OF, it's just representing that the traffic needs to be flooded to all ports within the same broadcast domain. Okay, that these nodes that are in the same broadcast domain, they're going to receive the traffic from the sender, right? Okay, so based on that fact, we have based on that part, we have LAN switch forwarding behavior. Okay, we're going to talk about that in a minute. But before I go,
I have one question related to what exactly you speak. I mean, for the switch is already use the single collision domain. It won't work on the broadcast domain, right?
no, basically the switch has, for example, if you have a 48 port switch,
okay,
the 48 port switch, it has 48 different collision domain.
Yes.
By default, it has 48 port collision domain, 48 different collision domain, but by default, it has only one single broadcast domain. One broadcast domain, and the number of collision domain is the number of ports on that switch.
Okay, understood. Thank you.
No worries. Okay. So one more thing before I want to go further into the topics, I just want to also tell you about the MAC addresses. Okay. So let's say I have this MAC address again, 1, 2, column 3, 4, and the way you can write down the MAC address could be different. Sometimes in some platform they're just dividing them for every 4 digits will be divided by a dot, or you can just divide it by the column. Depends on the platform. It may be divided. Even some platform to just put some dash in between. I don't have any problem with that. It's not look like the IP address. Basically, the IP address, the IPv4 could be either the IPv4 is dotted decimal, or the IPv6 is a column. It has a column and it has a hextet and the octet. But in here, in the MAC address, based on the different platform, you may have some separator. Maybe your separator is a dot or column or dash or something else. I'm not quite sure about that. So let's say I'm just using the column in here, 1, 2, column 3, 4, 5, 6, 7, 8, 9A, and BC. Okay. All right. So I just want to know whether this address is a unicast address or the broadcast address. How can I do this? If I want to specify, is it a unicast or the multicast or the broadcast? But simply is not a broadcast address, because the broadcast address is fixed. You cannot have any other broadcast address. It's going to be all consecutive F. 12 consecutive F is only representing the broadcast MAC address. How about this scenario? If you just look at this number, these are hexadecimal number. And the hexadecimal number is starting from 0 to F. The very first one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. It is an hexadecimal format, okay? It could be either 0, the beginning, or the F is the last digit. So it says 1, 2. How many bits is every hexadecimal number? Can you tell me about that?
Sorry, say again, please.
Basically, the MAC address is 48 bits.
Yes.
And we have 12 different digits. How many bits is every one of them? Can you tell me about that? 4 bits. Okay.
4 bits.
So basically, the 1 is 4 bits, and the 2 is also 4 bits.
Oh, yes.
All right. Clear?
Yeah.
Okay. So if you want to specify whether this MAC address is a multicast MAC address or the unicast, or simply you can say, is it an I stands for individual or a group MAC address, you need to convert these hexadecimal number into the binary, right? So the 1 is going to be 0001. This is going to be 1 to the binary, and 2 is 0010. Okay, and this is the 8 bits. IG. When it is 0, it means this is going to be a unicast address. Do you agree with me on that?
Yes.
Okay,
Yes.
it's going to be a unicast MAC address. How about this bit? It is 1, so it stands for local. Means that this MAC address is assigned by an administrator. Some network engineer just assigned this MAC address to the client, right? This is called universal or local. All right. Okay.
Yes.
Yes.
Clear. And the broadcast domain, as I told you, when the client is sending a traffic, only those clients that are in the same broadcast domain, they're going to receive the broadcast traffic from the other side. All right. Okay, guys, that's all for today. It's not going to be a very hard session. So this is going to be a practice session, not a real session for you. I just want to know, how do you feel about the class? Do you understand me well? Do you have any problem with those topics? These topics are basically so simple. It is going to be very theoretical. We're going to discuss about all of those things later in the lab. From tomorrow, we're going to start the lab session also. And the lab session will be about the 𝐊𝐢𝐧𝐠𝐬. From tomorrow also, I would tell you how to play with the 𝐊𝐲 machine. How can you deploy the 𝐊𝐲 images and bring up your own lab environment for yourself back home, and you can play with all of those different equipment at your free time. Anyway, if you want to use the networking equipment, the networking lab, you may also to do that. You can ask them your permission, and they can provide you also the lab access for the environment as well. All right. How do you feel about the class?
I have a quick question.
Sure.
I have a quick one. Yeah. So the local, the one, can it be 0 as well and still be called a local, or it has to be 1?
It has to be 1.
Okay. Okay.
But honestly, I can tell, nobody's just pushing you to do this. But anyway, most of the time when you're just changing that bit, you do not want to mess with yourself, okay? When you're just making an address for yourself, basically because you just want to show yourself in the future troubleshooting scenario, you just want to show it, this address has been assigned by me, not by the vendor itself. You're going to have this bit with 0, with the 1 value, not the 0. 0 basically means that this address has been assigned by the vendor itself, not somebody else.
Got it.
Sir, I
Thank
have
you.
a question.
So let's start with budget first of all, and then you can ask your question.
Sir, I just have a question. Is in the individual or group, like we have a 0, it's for the individual, or if there's a bit 1, there is going to be a group. Like in the
again,
individual.
I have a problem with hearing your voice.
Sorry, I'm repeating again. Maybe my voice breaking. Because we have the 0, that's why we said it's the individual. The bit is individual. But if we put the 1 here, that's going to be group.
Sorry, I cannot hear you. Again, I have a problem. The voice is breaking in the middle.
I can write it down, the question in chat, so you can ask any other one.
If you can type it in the chat box, that would be brilliant. Hashim,
Yeah,
sir, I have a question. Can I?
Sure.
Thank you. Sir, earlier you said that MAC address about, you told about MAC address. We know that MAC addresses are fixed. They are stamped on NICs by manufacturers. Are there any chances that I will mess up with this MAC address, like some program like MAC Changer, so that when I send any frame outside the LAN segment, are there any chance to get caught or something?
Yes. So can you repeat the question again? So you mentioned that you're using some MAC address changer application, right? Back there.
Yeah, yes, sir. Yes, sir. Yes, sir.
Sure. On what next?
So my question was, is there any chance that I will get caught by the by the FBI agents or cops?
Oh, no, don't worry about that. Okay, so no, you can change your MAC address simply. Okay, we have a cop here. Basically, there's a security guard here. Is Abdul Samad is the security guard, so he's not going to caught you by changing the MAC address. Okay, so you can change your MAC address easily without. No one is going to call to you for that specific reason. Most of the time, there are potential. Sometimes you will see the duplicate MAC address, okay? Because there are plenty of different vendor out there. You don't know them, especially with the Chinese products. They just use the shared MAC address. They have a very huge pool out there, and they're just putting all of those MAC addresses into the same pool, and they're just using that MAC addresses again and again and again.
Okay, sir. Thank you.
No worries. بله. خواهش میکنم بفهم. I'm deeply sorry. I'm so sorry about that. Okay, so this is the very first session that we talked about. Those Ethernet topics. I don't know why my telephone is just not muting. I just put it on an airplane mode, still ringing. I don't know, maybe this is my MacBook problem. Anyway, so as I told you, this is the very first session. How do you feel about my explanation? Do you feel comfortable with that?
Yes.
Yes, sir.
Yes, yes,
All right.
yes, yes.
So tomorrow, what we're going to do, we're going to have a lab session, okay? Just get your gear and get ready for the lab part. The lab part of the class is going to consisting of how to bring your lab environment, okay? We're not going to talk about anything technical, so we're going to set up your own lab environment. This is going to be very interesting for you, okay? It's going to be a very interesting session. Make sure that you're going to have your computer. Don't use your iPad or iPhone or something, because this is the only session that I'm going to provide you the lab setup environment, okay? I'm going to lead you to how to set up your lab environment. You need to cooperate with me on that session, then you can have your own lab environment back home, okay? Then later, when we are just doing a lab and a session, you can just make a copy of that. I'm going to give you the file. You can put it in your lab environment, and you can bring it up for yourself and start to doing lab wherever you are. You do not need to have an internet connection. This is going to be a very interesting session for all of you, right? Okay. Make sure that you're going to have everything ready for the tomorrow session. What do you need for the tomorrow session? Okay, I'm going to give you, guys, please listen to me carefully. I do not want to repeat that part again. Please listen to me carefully and listen, just do the exact same thing that I'm asking you, okay? First of all, download 𝐊𝐲 Community Edition. Guys, do not download the Pro Edition, okay? You do not need for the beginning, but later maybe you do need that part as well. Only download the 𝐊𝐲 Community Edition. Make sure that you download the community. If you don't download the Community Edition, I cannot wait for you, okay? Because tomorrow is going to be a very challenging session. Make sure to download the 𝐊𝐲 Community, or basically this is a free edition, right? Then also download PuTTY application. If you're using the Microsoft Windows, to download WinSCP, you can just Google this name and download from that site as well. And also download and install VMware Fusion for the Mac operating system, for Mac OS, or VMware Workstation for other client, or any other, any other type of virtual machine running application. You can just run the virtual machine. You can download any piece of equipment that you want, right? But these options are mandatory for the tomorrow session, right? Make sure to download them all.
Sure.
Okay, let me give you the 𝐊𝐲. The main website for the 𝐊𝐲 is eve-ng.net. You can go to the download part. Hold on a sec. Give me a second. Guys, I put the download link for the eve-ng on the chat box. Okay, you can download it simply from this drive.google.com that has been provided by this by the Eve website itself. Okay, do you see the links?
Yeah.
Yes,
Yeah.
sir.
All right,
The
brilliant.
same link be used for Linux?
Sorry, what is that?
Can we use the same download for Linux?
Yeah, you can use for the Linux. The only difference between the Windows and the Linux is that if you just run this image, that you need to download the OBF file. If you just download it, you can just run it in the Linux operating system natively. You do not need to set up the virtual environment as well. So if you're familiar with the Linux, you can just run it pretty easily. Okay, and guys, for the last part, also make sure to download this. If you're just using a Microsoft, download this Windows integration pack. Is there anyone here using the Mac OS? Anyone?
Yeah.
So I'm using the Mac OS.
I'm using Mac OS.
Okay, if you're using the Mac OS, you need to download the VMware Fusion instead of the VMware Workstation, and also you need to download the client integration pack. And that side, there is a website again here. The last link also is going to tell you the client integration pack. For the Apple OS X, you have another package. There's a DMG. And for the Windows, there's another application, but make sure to download those client integration pack. Is the pop-up being displayed while clicking Eve link? Kajal Rana says, sorry, you cannot view or download this file at this time. Is the pop-up being displayed while clicking on the eve-ng link? No, it should be okay. Anyway, if you Kaja, if you cannot download, there is a main website. You can click on the eve-ng.net and you can go to this part. Let me just share my screen. Hold on a second. Here we go. So here's the eve-ng website. If you want to download the free Eve Community Edition, and you need to download the eve-ng OBF from either the Google Mirror or the Mega Mirror, you can download them from these links, okay? But you need to download these free Community Edition version 5.0.1.13, okay? If you want to pay for that, if you're rich enough, you can download also the professional or the learning center. The learning center is not for you. Simply just download the professional edition and you can buy the license for the pro edition. And simply, let me just show it to you. How does it look like? This is the pro edition. It has lots of other benefits as well. So for those of you that you just want to have a very clean up scenario, you can have them in your lab environment like this. Okay, I guess, Michael, do you have a question?
No, I just wanted to find out, apart from what you've listed, is there anything else Linux users need?
No, simply you need to follow up the how to install. And the eve-ng website, there's a how-to part. You can just read that how-to part. If you don't want, just download the OB file and leave it to me tomorrow. I will tell you how to set up in the Linux operating system as well. right?
All right.
Okay, and anyway, guys, this is a Pro Edition. So with the Pro Edition, you have lots of other benefits, okay? If you want to play with that part, it support different colors. You can set up different colors on the links. You can have different type of styles. Basically, for the training, for the teachers, it's pretty good. For the students, it sounds good. But if you want to pay or if you want to use the free edition, this is your choice, all your choice. You can just choose any of them. Do you have any other questions?
Hi, Kevin. Running this mess of nodes in EVNG requires a lot of resources in the laptop, RAM and processor.
How much resource do you have in your laptop right now?
I am having 24 GB RAM and AMD Ryzen 7
Jesus
processor.
Christ, you have 24 gigabytes of RAM.
Yeah.
I think you do not have a sufficient amount of memory. You have plenty of, my friend, you have a lot, okay? 8 gigabytes of RAM would be more than enough, okay? We do not need to have a huge amount of resources for the lab environment. For the Encore and NRC, for the most of the scenario, the 8 gigabytes of RAM would be more than enough, okay?
All right.
Right. Okay, any other question, guys? Do you have any other question? Would it be okay? So brilliant, guys, for the tomorrow session, please make sure to download all of these applications. And if you want to set up your own lab environment, if you do have a free time, you can go to the eve-ng website, okay, eve-ng.net. Then you can move to the how-to part. There is inside the documentation part, there's a how-to button and there's an installation web page. Okay, you can go there and it's going to say how to do the virtual machine installation, the bare install. If you want to install in the different network environment, it's going to show you how to install in the Microsoft Windows, in the VMware workstation videos, and the VMware player video, how to install these kind of things. That will be all. And also for bring up the different images, there's a how-to button for different platforms, for different Cisco equipment, Juniper, Microtech, the pfSense, the Huawei application equipment. And for all of them, there's a how-to button here, and you can use those links to understand them as well. Can you share all links? Okay, the links is already there. For those of you that you're not familiar, so 𝐊𝐤𝐧𝐠𝐬 is the link is you need to go to the eve-ng.net website. Okay, so what do you need to read? For today's session, nothing, right? But the day after tomorrow, I will tell you what do you need to read and which book you need to go there and read the chapter. Basically, it's going to be chapter 1 of the CCI routing and switching version 5. But at the moment, don't worry about that. Just do install those equipments in your lab environment. Then later, during the weekdays, you can start the reading as well. Any other questions so far? All good? Happy?
If we have access to the labs, do we still need to download all of this?
Yeah, do it. Who was asking that question? That was a very good one. Who was that? Joshua?
Mm-hmm.
Okay, Joshua. Where are you, Joshua? First of all,
New York.
New York. Okay. So Joshua, can you for the tomorrow session make sure that you share your camera as well? Can you do this for tomorrow?
Mm-hmm.
All right, thank you. If you have access to the lab, what do you mean? Do you have access to the lab back home or in a networking?
The networking is that.
No. Just set it up for yourself as well. The networking would be okay. Very good, brilliant option for those long scenario, which it has a huge requirement for the resources. But you know, for the normal case scenario, when you need to set up, for example, 2-3 routers and back home, you do not have access to use the networking environment. Basically, the networking is just giving you some very fixed scenarios. You cannot add more or remove some of them. You can only configure those equipments within a lab. Sometimes you just want to set up your own environment. Okay, this is going to be very beneficial for you, right? Any other question? Good. All good. Happy. All right. That's all for today. Okay. For all of you all around the globe, I wish you all have a great day. Hello. Hello. Somebody has a question here?
Hello, Kevin.
Sure. Yeah.
Hello. Yeah. How you doing? This is Abubakar.
Okay, Abubakar.
I'm so sorry. I mean, yesterday I was the guy that hooked you up with Mohammed. I was going to pick up my server.
Sure.
I
No
don't know
problem.
if a guy reached out to you. Yeah. So he sells those servers, and I went there for, the Dell Power Edge R620. I just want to do it for my home lab though. So he's building them, and then he needed something, and I gave him your name. So I don't know.
Abubakar, can you do me a favor? I simply can you send me in the WhatsApp message? I'm just sharing my number in the chat box. For those of you that you are interested to communicate with me in the WhatsApp group, you can just send me your request in the WhatsApp. I just post my number in the WhatsApp in the chat box. You can just add me in the WhatsApp and send me your request over there, and we can discuss about any more
great.
problems.
All right, thanks.
Thank you very much. No worries.
Thanks.
I wish you all have a good day ahead. Have a good weekend. I see you all tomorrow. Make sure to attend the tomorrow session, and make sure to download everything and get your gear. Get ready before the tomorrow session. It's going to be very, very interesting to have your own lab back home. Take care of yourself.